Hey students, as promised in some of the comments I put in the discussion prompts that I just graded today, I wanted to do an example of changing a fraction to a decimal that terminates and knowing how to know whether it repeats or terminates. So I know there were videos after those discussion prompts, but it seemed like maybe some people could use another example or two. So I'm going to do the examples. I'm using the exact same method, but I think sometimes those videos, the ones that I don't do, they can be a little bit more fussy because they try to be so mathematically correct. So I'm using the exact same math, but I'm going to try to explain it a little bit better. So, all right, so we're going to start with, let's see, we're going to start with a fraction. Do like 23 over 100. And the reason I'm starting with this one is because we know what this fraction is equal to as a decimal, right? This might be something you don't remember that well, but you did learn it at one point in your life. So this is 23 hundredths, and that translates exactly to 0.23, which you read out loud as 23 hundredths. Remember, this is the tenths, that's the hundredths, and when you say it out loud, you say 23 hundredths. So it matches exactly. All right, anyway, so I know it terminates just based on the fact that if I write it as a decimal, it terminates. But if I look at the denominator, right, don't do anything to the numerator. I look at the denominator, and I factor that guy out. That's a 10 times a 10. 10 times 10 is 100. Remember that old trick where you just count the zeros. 1, 2, 0, so it's 100. Each of these guys is a 5 and a 2. Alright, so it's 23 over 5 times 2 times 5 times 2. Right? So here's the thing to notice. When you've got one that's got a power of 10 on the bottom, you've got an even number of 5s and 2s, because a 5 times 2 is a 10. And then if you only have 10s that are multiplied, you're going to get one of those powers of 10s. 10, 100, 1,000, 10,000, and so on. Okay? All right, so we're going to use this, and you know, that learning through problem solving activity, you guys did a tremendous job at figuring out the 5 and 2s thing. I think 3 of the 5 groups figured out a method for switching it to decimals, which I thought was really great. I know it was tough. All right, so I'm going to do 23 over 80. I must like 23 as a numerator. All right, so I'm going to take 80, and I'm going to split it up, and that's 8 times 10. All right, and 10 is 5 times 2, and 8 is 4 times 2. And I've got 2 times 2. All right, all I have are 5s and 2s. Nothing other than a 5 or 2, so I know it terminates. Now it becomes my job to write it as a terminating decimal. Here's the trick. If I can get this 80 to turn into a power of 10, so 10, 100, 1,000, 10,000, I will be able to write it without doing any other work. So I'm going to start. I'm going to write it like this. 23 over 2 times 2 times 2 times 5 times 2. All right, remember up here, the number of 5s and 2s were equal, and so that made it always come out to be 10 times 10. I want to do the same thing here. I've got one grouping that's 10. I need a 5 for each one of these guys. So what I do is I multiply by 5. That gives a 5 to each one of these 2s. If I do something to the bottom of a fraction, I got to do it to the top of the fraction. Okay? So remember, look what I'm doing here. I'm saying I'm going to give this 5, it's going to go with that 2. This 5 goes with that 2. This 5 goes with that 2. So I'm going to have 10, 10, 10, and I already had one 10. So when I do the bottom, I don't really, if I know the trick, I don't have to work hard. So I know it's going to be a 1 and 4 zeros. Okay. The top, I am grabbing a calculator. Hold on. I'm going to multiply this. So that's 23 times 5 times 5 times 5. And I get 2,875. Okay, so 2,875 ten thousandths. That's 0.2875. Okay. All right, so notice I used my calculator to multiply, but I never used it to divide. And even long division isn't what I was after on here. Some of you tried that, but that's not what I was after. All right, try the next one. So I'm going to take my 32. Right, that's 16 times 2. 8 times 2. 4 times 2. 2 times 2. All right, I got a bunch of 2's. All right, so I've got 17 over 2 times 2 times 2 times 2 times 2. All right, only 2's or 5's, which is another way to say, I'd like, a couple students said it this way, nothing other than a 2 or a 5 shows up, so I know it terminates. All right, if I want to make this to have a power of 10 as the denominator, each one of these 2's needs a 5. Because 2 times 5 is 10. So I multiply. I got to do top and bottom. 5. And in the video that I had already linked, that you guys hopefully watched, they wrote it as 5. They would have written this as 5 to the 5th power. And I thought maybe I'd take the exponents out, and that might help some people who don't like the fancy notation, because sometimes notation just makes things harder. All right, so each one of these 2's now has a 5 to go with it. So I've got 10 times 10 times 10 times 10 times 10, right? So that is a 1 with 5 zeros. All right, grabbing calculator again, hold tight. So I've got 17 times 5 times 5 times 5 times 5 times 5, and I get 53,125. And I can write that as a decimal. It's 0.53125. All right, hopefully this is helping. I'm going to do one more. So I'm looking at 56 over 75. All right, that's 3, times 25. 5 times 5. All right, so I've got 56 over 3 times 5 times 5. All right, I have a number that is not a 5 and is not a 2. Right there. This guy's going to repeat. So I'm not going to be able to write it as a decimal without a calculator. I just can't do it. I'm using the example because I want to point something out here. All right, so I could try to do the same thing, but it's not going to work, okay? So I could give this 5 a 2, right? 2 times 5, that would be 10. And I could give this 5 a 2, right? That 2 times 5 would be 10. Now think about this. I need to have just 10's down here so that when I multiply, it's like 10 times 10 times 10. What would you multiply 3 by to get 10? I mean, 3 times 3 is 9. 3 times 4 is 12. So it's somewhere in the middle. It's not a fraction that you can name. Okay, so it's 10 divided by 3, which comes out as a repeating decimal. So it's not going to work out. So that's why I can't make this 3 multiply by anything to give me exactly 10. So therefore I can't use this method to turn it in to a decimal. And we know that it's a repeating decimal because that 3 is there. All right, so hopefully that helped. Did you make it through my screencast? Let's see. If you got through the screencast sometime before you take the exam, all right, send me an email. And how about writing 56 over 75 repeats? Okay. All right, so some of you have been reading all of my announcements and watching my screencasts, and I know they can be very boring. Trust me, I no illusion that they're exciting. But some of you have been doing that, and when you do that and you send me these emails, you get some extra points. It's going to happen again. So if you watch all the way through this, all you got to do is send me an email before you take the next exam that says 56 over 75 repeats. That's all you got to do. Hope to hear from you. Bye.